Hello there, welcome to Augmentech. In this session, we are going to discuss about centrifugal pumps. So what you will learn in this session? We are going to learn about centrifugal fire pumps. Then what are the types of centrifugal pumps are available in firefighting system? Then about end suction versus horizontal split case pump, centrifugal fire pump selection criteria, then about centrifugal fire pump capacity. So let's start. Now see about centrifugal pumps. So in that it is written centrifugal pumps are the most common fire pumps and are used with most system. Okay. So with centrifugal pumps, pressure is developed principally by the action of centrifugal force or spinning. Water is centrifugal pumps enter the suction inlet. Here when you see in this figure, water in this centrifugal pump enters the suction inlet. This is our suction inlet and passes to the center of the impeller, okay, and discharge through this discharge line. Okay, now these pumps have a spinning impellers that draws the fluid into the pump and forces it out of the outlet point at an increased velocity. Why we are using pump? So it is clear that we have to increase the pressure, okay, or we have to increase the velocity of flowing fluid, okay. So for that we are using pump. Centrifugal pumps can handle large volume of water while providing high pressure boost. As we know that in firefighting system, we are using two types of pump. Okay, first we have positive displacement pump, then we have a centrifugal pumps. So generally, positive displacement pump is what we have already discussed. Centrifugal pumps we are using for large volume. Okay, remember if you have a high capacity range, so on that time we are using this centrifugal pump because this pump has the capacity to handle large volume of water. Okay, the fluid moving out of centrifugal pumps is a varying flow rate based on pressure. Okay, now see here we have a centrifugal pumps. In that we have a different component. First, this is our delivery pipe. It means from here only we have to connect the pipe if you want to discharge water to each and every point where you want to discharge it. So from here we have to discharge our water. Okay, now here we have a driver shaft or driving shaft. So what is the use of this driving shaft? So remember impeller, when you see in this figure here we have an impeller. The impeller is mounted on a shaft. Okay, a shaft, why we are using shaft here? A shaft is a mechanical component for transmitting torque from the motor to the impeller. Okay, so this is the main function of driving shaft. Now when you see here we have an impeller. So what is the use of impeller in this centrifugal pump? First, remember the impeller is mounted on a shaft. Okay, and why we are using impeller is a rotor, just like a rotor. It is used to increase the kinetic energy of the flow. Okay, our main target is what? By using impeller, we have to increase the kinetic energy of the flow. Now remember one point: impeller design is the most significant factor for determining the performance of a centrifugal pump. Okay, a proper design impeller optimizes flow while minimizing turbulence and maximize efficiency. Okay, and we have a different types of impeller: open impeller, semi-open impeller, then we have a closed impeller. Generally in open impeller, these open impellers have the vanes free on both sides and they are typically in small dia available. And if I talk about semi-open impellers, so these semi-open impellers have the vanes are free on one side and enclosed on the other. and they can used in medium dia. Same way, this closed impeller have the vents are located between the two discs all in a single casting, and they are used in large pumps. Okay, so this is about impeller. Now the next, it is written as suction pipe. So the water which we have taken from either underground, suppose if you want to transfer water from underground tank to overhead tank, suppose, and you are using pump, so water will enter from where? Suction pipe. Okay, and suppose if water is coming from municipality, so they enter into the pump from this line only. Okay, suction line. So, and remember your one point, these centrifugal pumps are provided with packing rings or mechanical seal, okay, which helps prevent the leakage of the pump liquid. Okay, that is why here we have to give the mechanical seal. Now the next one is casing. So the casing contains the liquid and act as a pressure containment vessel that directs the liquid flow in and out of the centrifugal pumps. Now here we have a schematic diagram of this centrifugal pump, means section drawing of this centrifugal pump. Inside, this is our casing of centrifugal pump, and here we have a volute chamber. Casing is what I have already discussed. A volute chamber. So this volute chamber, a spiral shaped casing around the impeller, okay, of a centrifugal pump. And why we are using this volute chamber in this centrifugal pump? So it is used to convert kinetic energy of the flowing fluid into the pressure energy at a point of discharge. Okay. So this is the main purpose of using volute chamber. Okay. Now here it is, here we have a impeller vents. So as I already discussed that we have a three types of impeller: open impeller, semi open impeller, closed impeller. Okay, and impeller blades can be backward curved, radial or forward curved. Based on your requirement, you have to use that which type of uh, impeller blades you want. Okay, now here we have a impellers. Okay, then we have a drive shaft eye. So this impeller is mounted on the drive shaft eye only. Based on that shaft only, this impeller rotate. Fluid or liquid will enter from this side. Okay, this is our inlet point, and by rotating the impeller, pressure of this liquid will increase, and then we have to discharge. So now my question is how this centrifugal work. Okay, so remember, centrifugal type fire water pumps generate centrifugal forces by rotating their impellers, okay, and throwing the water from the center of the impeller to the outer part of the impeller. Centrifugal fire pumps are used for high flow rate to provide a constant water flow, mainly for building, utility station, etc. Okay. So a fire pump in a fire sprinkler system normally receive water from either an underground water supply or a water tank, lake or reservoir. Okay. These pumps are is powered by electricity or diesel fuel. If there suppose due to absence of electricity, on that time we have to use what diesel fuel or diesel engine, okay, to operate this pump. So the high pressure supplied by the fire pump helps in the proper distribution of water through the sprinkler system and hose standpipe system. So this is all about centrifugal pumps. I hope all of you understand properly about centrifugal pumps. Now see the types of centrifugal pumps. So in that, first we have a horizontal split case pump. So this pump is installed with a split casing that can be opened or pump maintenance access. Okay, they are very this pump, horizontal split case pump, are very reliable and come in a wide range of rated flow and pressure capacities. Are easy to maintain due to their relatively easy split case access. Okay, and can be used with both electric and diesel driver. However, these also typically need the most space of all types of fire pumps. Okay. Now, in this horizontal split case pump, suction and discharge nozzles are in the bottom half of the casing, side by side. Okay. The impeller shaft is positioned between two bearing. Here in this pump, the impeller shaft is positioned between two bearing, one on each side. I think all of you know about bearing. Bearing we are using for what purpose? Bearings constrain the relative motion of the shaft, okay, and reduce friction between the rotating shaft and the stator. So this is the main purpose of using bearing. So in this pump, the impeller shaft is positioned between two bearings and it is connected to the driver by a horizontal shaft. The flow is split in this pump. The flow it is split. You can split the flow and enter the impellers from opposite sides of the pump housing. Now, when you see, if I talk about the advantages of using this horizontal split case pump, so there are many advantages. First is rugged but simple design. Design of this horizontal split case pump is simple as compared to other pumps. Now it is suitable for higher flow applications. Suppose if your flow rate is high, means for high capacity application, you have to use this pump. Okay. Now it reduces thrust load also. So there are many advantages of using this horizontal split case pump. Now it is written with proper application. Horizontal split case pumps offer what? First, tell me that where we have to use this horizontal split case pump, because remember this point, this pump we are using, we have to use for higher flow application. Okay, just like this pump is used for pressure boosting for high rise building, hotels, okay, industry, etc. And this pump is also used for fire protection system, cooling and air conditioning system, and we can use this pump for irrigation system for field including sprinkler, okay, and drip irrigation system where you have to use this type of pump. Now the only disadvantage of this horizontal split case pump is what? It requires more space as compared to other pumps. Okay, now it is written with proper application, horizontal split case pump offer what? Minimum power consumption, low maintenance cost, and extended service life. Now here remember one point, these horizontal split case pumps are available in two main design. What are they? Single state and two state. So single state horizontal split case pump has what? Head up to 550 feet and flow rate 1,40,000 GPM. Okay, it will be available. If I talk about this multi-stage horizontal split case pump, so it is available with a maximum head of what? 2200 feet, or maximum operating pressure of this multi-stage horizontal split case pump is 740 psi and flow rate range of up to 2000 GPM. It is available. Okay. Now, this type of pump, horizontal split case pump, have many benefits. The first, it is the pump in this type of pumps are non-self priming. Horizontal split case pump with radial suction port and radial discharge port. Okay, and these pumps are available with gland packing as well as mechanical shaft seal. So this is all about horizontal split case pump. Okay. Now, the second types of centrifugal pump is vertical turbine pump. So, vertical turbine pumps are a type of rotodynamic pump that use radial or modified radial flow impeller in a vertical configuration. Especially this type of pump, vertical turbine pump, especially designed for firefighting application as per NFPA 20. Okay, as we know that NFPA 20 is what? is the standard for installation of stationary pump. Okay, so they are special designed to pump from water source located underground or below deck. Suppose if your water level is, if you want to suck water from underground tank and you have to supply the water to any fire protection system, suppose sprinkler system, hydrant system, so on that time you have to use, or suppose if your water is below deck, so on that time we have to use this type of pump. Where there is where we have to use, so where there is no possibility to install a horizontal fire pump, suppose if your space requirement is less, okay, on that time you have to use this type of pump. Now these pumps can be used with raw water sources such as ponds, lakes and rivers. It is the only type of pump allowed by NFPA 20 that can start with negative suction pressure or take water under a lift condition. Okay, vertical turbine pumps come in a wide range of capacity and pressure, and they can be used with diesel and electrical drivers. Okay, so the this capacity and pressure available, there are the flow rate of this vertical turbine pump, minimum 50 and maximum up to 6000 US GPM flow rate available, and pressure rating up to 2.76 to 26 bar. Speed rating is around 1450, means for 1450 to 2950 rpm speed rating is there on, okay, for vertical turbine pump. So this is about vertical turbine pump. Now the another types of centrifugal pump is inline pump, inline centrifugal pump. So inline pumps are useful where space is limited. Okay, remember where we have to use this type of pump, where space is limited. Okay. Now these can be driven by both a vertical or horizontal shaft. As per your requirement, you have to select the fan, which type of fan you want actually. Okay, then vertical shaft type have the driver located directly above the pump. Okay, vertical shaft type are the most common. Generally the inline pump we are using, so it is of vertical shaft types only. Okay, here we have a different component of inline pump. In this, when you see in this figure, up portion of this inline pump, we have a motor. So electric motor driven firefighting pump is used in multi-story building and in industrial plant also. We supply electric motor driven firefighting pump for all over the world. Okay, generally the pump which we are using in firefighting system, it is of electric motor drive. Okay, now here we have a shaft sleeve. So a shaft sleeve is a hollow metal tube, cylindrical in shape, which is mounted over a shaft and shaft assembly to protect it in corrosive environment. Okay, and these shaft sleeve are commonly found in single stage pump. So this is the main function of using shaft sleeve in inline pump. Now here we have a suction flange. From here water will enter. This is our casing of pump, and here we have a discharge flange, means from here water will discharge. Where you want to discharge or where you want to supply the water, you can supply it. So the suction flange and discharge flange are on approximately the same plane. Okay, remember this point. Here we do not have any concept that suction is in horizontal and discharge port is perpendicular to suction. Here remember, suction and discharge both are in same plane. If I talk about this vertical shaft type of pump, so vertical shaft types are the less expensive unit and take the least amount of space also. That is why it is common use pump. Generally we are using this type of pump only. So they are also one of the more expensive to repair. Pump maintenance and repair can be difficult. Why? because the motor must be lifted off and removed to gain access to the pump, unlike a split case unit. And they have a limited capacity of typically no more than 1500 GPM. Remember, it will be available up to 1500 GPM only, the capacity range. Okay, if your capacity is more than 1500 GPM, on that time you can go another pump. We have a horizontal split case pump, but only the limitation of using that pump is what? Space requirement for horizontal split case pump is highest compared to other pumps. Okay, now they can only be used with an electric driver, which limits their potential application. Okay, so this is all about inline pump in firefighting. Now see the another types of centrifugal pump is what? End suction pump. An end suction pump has a discharge outlet. When you see in this figure, here we have a discharge outlet perpendicular to this suction inlet. In case of inline fan, what happened here? In case of inline fan, we have a suction or discharge outlet is in same plane, but in end suction pump, this discharge outlet is perpendicular to the suction outlet. Means water we supply from this suction inlet and discharge from here discharge outlet. Okay. So these pumps are typically limited to a capacity of approximately 1500 GPM only. Okay, so you can use, but if I compare both inline and end suction pump, so this end suction pump require more space as compared to inline. Okay, so it is based on your space available in your site. Based on that, you can just install your pump. So compared to if I compare this pump and suction pump to horizontal split case fire pump, so they are more compact and required less installation space. Yeah, if you compare this end suction pump to horizontal split case pump, so this end section pump required is more compact also and require less installation space as compared to horizontal split case pump. Remember, okay? But if you compare this pump to inline pump, so this end section pump required more space. Okay, end section pumps can be used with either an electric driver or a diesel driver, both. Remember, the discharge range is given for end section pump 50 to 1000 GPM. Head range is given 5.5 to 14.2 bar, and rated speed of motor is given 2900 to 3000 rpm. Okay, since in this pump what happened, water is entering one side of the impeller, and due to the design of impeller overhang, these pumps cannot be used for large water flow application. Okay, this is the disadvantages of using end section pump, because you cannot use this pump for large water flow application and usually not exceeding 1500 GPM. Remember. Now the next is our multi-state multi-port pump. Now see about multi-stage multi-port pump. This pump uses a single driver that can be either an electric motor or a diesel engine, and it connect to a pump with multiple impellers. So generally in this multi-stage multi-port pump we have a multiple impellers in series. Okay, so in this multi-stage multi-port pump, we uses a single driver. Okay, and it connect to a pump with multiple impellers in series in a single casing driven by a horizontal shaft. The casing has multiple ports or outlets delivering different pressure. Okay, each port has increased pressure from the consecutive series impeller. Here, a shut-off valve shall not be required between the impeller of a multi-stage multi-port pump. So where we have to install? So suppose if you have a high-rise building, okay. Now the question it is coming, I think for all of you mind that where we have to use this multi-stage multi-port pump. So suppose if you are designing, if you want to install this pump in high-rise building, suppose high-rise building in some zone, suppose we have categorized that building in 3 to 4 zone. Suppose in one zone we need different pressure, in another zone we need different pressure, so on that time you have to prefer this type of pump. Okay, now see here I am taking one example. See, here we have a high rise building. Okay, for example, one multi-stage multi-port pump could be installed in a high-rise building having 30 floor. Assume that floor is how much? 30 floors. Okay. So the building may be divided into three zones. Okay. Where a multi-stage multi-port pump equipped with three discharge outlet would use each outlet for a zone. Here we have a three zone when you see. Okay. So the first zone which is showing in figure, outlet pressure. So the first zone outlet pressure of 100 psi means around 6.9 bar, and feed lower floor. Lower zone, you can say ground to ninth. Okay. The second has an outlet, how much outlet pressure? 150, 175, different pressure. See, in every zone we have to discharge the water at different pressure. So the second, suppose the second has an outlet pressure of 175 psi and feed middle flow. This will feed middle floor or mid zone 10 to 19. Okay. And a third has a discharge pressure of 300 psi and feed the upper flow or high zone or 20 to 30 floor. Okay, so if you need different, means if you want to discharge water to each and every zone for different pressure rating, so on that time this multi-stage multi-port pump is best, so you can prefer this type of pump. Now using multi-port fire pumps could result in what? Could result in no requirement for water storage tank or intermediate floors. So here we do not have requirement of water storage tank or intermediate floor. Okay, on intermediate floor, because if you use another pump, if you use another pump on that time we need water storage tank on intermediate floor. But if you are using multi-stage multi-port pump, so here we do not require any water storage tank on intermediate floor. Okay, now the second one, less pipe work and fewer valves, means if you use this multi-stored multi-port pump, so you required less pipe work and fewer valve, as one pump could eliminate the need for some control valves and pressure reducing devices, lower structure loads and associated cost also. Cost, as only one pump may be required here, don't need to buy another one pump for one zone, and another zone we have to install a second pump. So here only one pump you have to use for uh, high rise building. So this is the advantages of using multi-state multi-port pump. Another one, energy conservation, because less electricity and or fuel will be consumed in this multi-stage multi-port pump as compared to other pump. Now see the next topic, end section pump versus horizontal split pumps. Okay, so in that see all of you, here we have a suction pump, and what is the difference, main difference between this suction pump and horizontal split case pump? So generally if I talk about capacity range, so this end section pump we are using for what capacity? Usually not exceeding 1500 gpm of flow, means end section pump will be available up to 1500 gpm of flow, and horizontal split case pump used for very large water flow in excess of 5000 gpm, means up to 5000 gpm flow. For flow rate you can use this horizontal split case. It means horizontal split case pump you can use for a large capacity. Okay, but end section pump it is only available up to 1500 gpm only. Next, if I talk about initial cost for both, so this end section pump initial cost is low as compared to horizontal split case pump, because in his high horizontal split case pump high initial cost is high. So obviously, because here the flow rate is how much for suction pump? 1500 GPM it is available only. It means the size of pump, if you compare to horizontal split case pump, the size of end section pump is less as compared to horizontal split case pump. If size is less, it means cost is also initial. Okay, so what happened here? Due to the large flanges required for the split casing sealing joint, larger impeller and overall large size, horizontal split case pumps are normally heavier and cost more than comparable end section pump, which has lower initial cost. Okay. Now about maintenance. So when you see in this end section pump, more difficult. Maintenance is more difficult due to their compact design. But in horizontal split case pump, maintenance easy for maintenance as the top half of the casing can be removed. Okay, because here in horizontal split case you can remove the half of the casing easily. So horizontal split case pumps are easy for maintenance as the top half of the casing can be removed. So the internal components are like bearing, shaft, impeller and etc. are exposed without disturbing the suction or discharge piping or moving the motor. On the other hand, maintenance of end section pump are more difficult due to their compact design. For example, the removal of the impeller requires removal of the motor to provide a space for pulling the impeller back out of the casing. So here we have to follow some difficulty in end section pump as per maintenance purpose. Okay. Now the fourth one is space required. So this end section pump space saving by means of its compact design. Obviously, if it is it save space. This horizontal split case require more space as compared to end section pump. Okay, and here remember one point. The one advantage of end section pump is what? Here when you see now here in between this end section pump and horizontal pump, horizontal split case pump. So here we have a many benefits of using horizontal split case pump, okay, instead of end section pump. But the only one disadvantage is you can say space requirement is more for horizontal split case pump as compared to end section pump. But the one advantage of end section pump is that it is space saving. Remember, only the one advantages of end section pump using your what it is space saving by means of its compact design, while the horizontal split case pump required more space. That is why if your space requirement, suppose inside if you have less space, so on that time we have to install this end section pump only. Okay, we have not to see about this initial cost, maintenance and space, because inside the problem occurs what space requirement. Okay, on that time we have to prefer this only. If suppose if you have more space, so is okay, we have to select this horizontal split case pump only. So this is about the difference between end section pump and horizontal split case pump. Centrifugal firefighting pump selection criteria. So what is the selection criteria of centrifugal firefighting pump? So typical the selection criteria for centrifugal pumps are their design data like flow rate or capacity, discharge head, speed of rotation and net positive suction head. It's depend on this design data. Okay, the property of the fluid pumped, the application, the place of installation and the applicable regulation, specification, laws and codes. So totally the selection of this centrifugal pump is based on this all design data. Remember, here the first in while selecting this centrifugal pump we have to follow this thing: the greatest single demand for any fire protection system connected to the pump is less than or equal to 150% of the rated flow of the pump. Okay, second, the selection criteria for centrifugal fire pump is what? Shut off head shall be less than or equal to 140% of rated head. Third criteria, At 150% of rated capacity, head shall not be less than 65% of rated head. Note that here the performance of the pump when applied at capacity over 140% of rated capacity can be adversely affected by the suction condition. Application of the pump at capacity less than 90% of the rated capacity is not recommended. Okay, remember this point. One more point, remember that the selection and application of the fire pump should not be confused with pump operating condition. Okay, with proper suction condition, the pump can operate at any point on its characteristic curve from shutoff to 150% of its rated capacity. So this is all about the selection criteria of centrifugal firefighting pump. Now the next is what centrifugal fire pump capacity. How to calculate the centrifugal fire pump capacity? So remember here, I have already discussed the selection criteria of firefighting centrifugal pump. Okay. So a centrifugal fire pump for fire protections shall be selected so that the greatest single demand for any fire protection system connected to the pump is less than or equal to 150% of the rated capacity of the pump. Okay, remember. So this greatest single demand for fire protection system is always less and equal to 150% of the rated capacity of the pump. Okay, now here when you see here, here we have one table. So in this table we have a centrifugal fire pump capacity is given, some standard capacity is given, 25 gpm, 50 gpm, 300, 400, up to 5000 gpm rating is this capacity of this pump is given here. So here remember one point, centrifugal fire pump shall have one of the rated capacity in GPM, any capacity as per your requirement you have to select, but remember shall be rated at net pressure of 40 psi or more. Okay, not less than 40 psi. Remember while designing, while calculating the capacity of centrifugal pump, we have to remember this point, net rated at net pressure of 40 psi or more pressure we have to take, not less than 40 psi. And capacity, as per our requirement you have to select the capacity. So this table which I have shown you, this table I have taken from NFP 20, okay, 2019 version, table number 4.10.2. when you go on that you get this table. Okay, remember, suppose here my question is, suppose if my capacity, if I take more than 5000 gpm, suppose if my capacity is over 5000 gpm, so what happen? Can I use capacity of this pump more than 5000 gpm? Centrifugal fire pump with rating over 5000 gpm shall be subject to individual review by either the authority having jurisdiction or a listing laboratory. Okay, so we have to follow this concept. Now see the next topic, comparison of pump. So we have discussed up to here different types of pump, horizontal split case pump, then we have discussed about end suction pump, then vertical inline pump, then vertical turbine pump. Okay, so we have discussed different type of centrifugal pump, but remember if I talk about that already we have discussed four types of pump. So these pump, centrifugal pump, are generally categorized into two form only, horizontal centrifugal pump and vertical centrifugal pump, because this both horizontal split case pump and end suction pump comes under which category? Horizontal centrifugal pump category only. And vertical turbine pump and vertical inline pump, that both pump comes under vertical centrifugal pump category. Okay, so if I compare this both horizontal centrifugal pump and vertical centrifugal pump, so remember in horizontal centrifugal pump position of shaft is horizontal, but in vertical centrifugal pump position of shaft is vertical. That is why horizontal pump we are calling that Yeah, if suppose if your shaft position is horizontal, so we have to tell them what horizontal centrifugal pump, okay, otherwise vertical centrifugal pump. And remember, this horizontal centrifugal pump required more space as compared to vertical centrifugal pump, okay. And remember, this horizontal centrifugal pump cannot handle more pressure and temperature of fluid on suction side, but vertical centrifugal pump can work efficiently with higher pressure and temperature condition, okay. Now this horizontal centrifugal pump cannot be altered net pressure suction head, net positive suction head, but vertical centrifugal pump can be altered net positive suction head as per requirement, remember, okay. If I talk about that who is more efficient, so centrifugal horizontal centrifugal pump is more efficient or high efficient as compared to vertical centrifugal pump. And in this horizontal centrifugal pump, we do not require any priming, okay, self except self priming pumps, okay. So here in horizontal centrifugal pump we do not require priming, but in vertical centrifugal pump, sorry, not in horizontal centrifugal pump we required priming, okay, but in vertical centrifugal pump we do not require priming, remember. If I talk about the maintenance and installation, so who's best better? So remember, horizontal centrifugal pump is easy to maintenance also and installation. Why? By you in horizontal centrifugal pump you can just open your half casing and you can do anything, maintenance and all. But in vertical centrifugal pump, due to its compact, so that is why it is not easy to do the maintenance in vertical centrifugal pump, okay. Now see here, we have discussed the different types of pumps, okay. So as based on that pump, what how we can compare all that pump. See in this table here, in first column it is given pump type. In that we have a vertical inline pump and suction pump, horizontal split case pump, vertical turbine pump, okay. Now this vertical inline pump, if you talk about space requirement, so it vertical inline pump is space saving, means it requires less space. This end section is comes under horizontal centrifugal pump category. It also required less space, means it is also a space saving. If suppose if any condition client is telling you that we have they have to install horizontal centrifugal pump, okay. And we know that in horizontal centrifugal pump we have two pump, horizontal split case and end suction pump, because both are horizontal only. They tell you that they have less space, so we have to install, but we have to install horizontal centrifugal pump only. So if you compare both this pump, horizontal split case or end suction pump, so this horizontal split case pump required more space as compared to end suction pump. On that time we have to prefer what, end suction pump only, because it is also a space saving, okay. Now comes to our third pump, what is horizontal split case. So this pump generally we are using for high capacity, means higher, where you need higher flow and pressure. On that time we have to use this horizontal split case pump, okay. Now remember here, where we have to use vertical turbine pump, anywhere you cannot use this pump. Suppose if you have a compact space and you have to install the pump, okay, on that time you can select vertical inline, okay, but you cannot use on that time vertical turbine, because only that area you have to use vertical turbine pump where water source is below pump. Suppose if you are you want to take water from lake, ponds, okay, or river, with the help of pump you want to suck that water and discharge to your point where you want to discharge, you want to transfer water anywhere. So on that time you have to select this turbulent sorry vertical turbine pump. It is all you where you have to use where water source is below pump. Okay, so remember this point while installing different types of pump in firefighting system. We have to remember all this point. Okay, so this is about our comparison of different types of pump used in firefighting system. I hope all of you understood properly about this comparison. The topics which we have covered in this session is what? First of all, we have discussed about centrifugal fire pump in depth. Then we have discussed about the types of centrifugal pumps available in firefighting system in depth. Then about what is the difference between end suction and horizontal split case pump, that also we have discussed. Okay. Then we have learned about centrifugal fire pump selection criteria, means what are the criteria of selection fire pump. Then we have learned centrifugal fire pump capacity, that what is the criteria, how we can calculate the capacity of fire pump. So we have seen that also. So this is all about centrifugal fire pump. I hope all of you enjoy the session. See you in next one.